好，那今天的那个书报讨论，因为那个王老师有点事情，所以就由我来介绍今天的讲者。那今天的讲者是于植章博士，那他也是中央资工的博士班毕业，算是你们的学长。然后于博士之前在这个万能科大担任过教职，然后到系主任，然后后来到资策会的教研所。然后后来他加入了一个新创的公司，就是这个 Outing Group。那等一下于博士可能也会介绍一下。那于博士今天会讲他们公司在导入这个把 AI 的一些技术导入产品的一些经验。好，那我们就掌声欢迎。那Dr. Yu will be giving his lecture in English. So since we have a lot of foreign students, so the talk will be in English. 好，今天会用英文来讲。我们欢迎于博士。
Okay, thank you. Hello. Today I'm going to talk about how we use the artificial intelligence technique in e-commerce platform. So, firstly, I would like to introduce our company for a little bit. Outing.com, we started from selling high-quality foods in Taiwan about 3 years ago, and we sell fresh milk from local farms and organic fruits around Taiwan. For now, we have 140,000 likes on Facebook. So in last year, we expanded our business in tourism industry. What we want to do is to provide impressive local experiences for travelers around the world. For example, we have a kayaking tour in Yilan and Hualien, and we have mountain hiking tours in Hualien, Tarugo, and Yushan, and we also have snorkeling experiences in Okinawa and Ryudao. So that's what we do right now. So the question here is, why do we need AI techniques? The reason is very simple, because we are a startup company and we don't have enough manpower. So we need the AI techniques to help us to do some routine jobs. And we also use AI as a value-added service. So in that case, our manpower can be optimized and used efficiently. So the interesting point is, do we have to develop a powerful AI? The answer is negative, because developing a powerful AI takes a long time. And for a startup company, your main goal is to survive. So you don't have so much time to develop a powerful AI. So what we want to do is just, we have an AI technique and we just want to make our system or our service seem not so stupid. And that's enough. The applications we used, we incorporate with AI, has two main applications. The first one is the recommender system, and the second one is the chatbot. So firstly, I would like to introduce the recommender system. So what is the recommender system? A recommender system is to make personalized recommendations for an item. For example, I know you like item A, B, and C. Can I know whether you like item D or not? That's what the recommender system does. So many popular companies are using a recommender system, like the Amazon, they recommend you their products. The Netflix, they recommend you some movies. And Spotify, they recommend you music. And YouTube, they recommend you videos. Something like that. For If you want to build a recommender system, an intuitive method is to analyze their contents. So you can make a lot of metadata, such as tags, to mark these items, and you simply recommend those items with similar tags. However, this is not suitable for our application because the e-commerce platform is operating for 3 years, and there are thousands of items are selling right now, and we do not have metadata of them. So what we are thinking is, can we recommend items without knowing their contents? The answer is yes. The technique here is called the collaborative filtering, or CF in abbreviation. The collaborative filtering is to analyze historical data of customers' interactions on items. So it's something like a crowdsourcing algorithm. So who is using CF? A very famous company, Amazon, is using CF right now. If you go to Amazon's website and you randomly click an item, you will find a sentence in the middle, say, customers who bought this item also bought, blah blah blah. And in this session, they use CF techniques to recommend items to you. So the types of CF, there are 2 types of collaborative filtering technique. The first one is the memory-based method. And the memory-based method can be further divided into a user-based CF and an item-based CF. What is the user-based CF? The idea of user-based CF is to guess your interests by collecting other people similar to you. So if the system found that there are a group of users who watch same items as you, the system will recommend you other items you haven't watched but watched by them. And the item-based CF is to recommend you similar items based on the relationship between items. So why? Because people usually buy related items together. For example, if you buy a cell phone, usually you will buy a cell phone case and a screen protector as well. So, and those are related items. So it can be the relationship can be found by using the item-based CF. So how to implement the CF algorithm? Firstly, you have to create a user item matrix. Assume that you have m users and n items. You can create an m by m matrix. And inside this matrix, it represents the interactions between all users and all items. For example, the value in the red circle may represent the behavior of the second user on the last item. And this value could have a lot of meanings, like it can represent the user like this item or not, or it can represent the user's rating on this item, or he did purchase this item or not. So if you want to guess whether the user A like an item or not, first you have to find those users who are similar to user A. So you can grab a row here And in this row, it is a one-dimensional vector, right? And it represents the specific user interacts. It represents the interaction between this user to all items. So you can easily imagine that for similar users, the vector should be closed. So you can use any kind of similarity measurement functions to find the similarity between these two users. And the most frequently used function is the cosine similarity matching. So you can find, give you a user A, you can find a lot of similar users who are similar to user A. Then you can use the ratings from those similar users to calculate the prediction for the active user. So this is how the CF method does. I would like to sit down. So the memory-based CF works very well when you have a dense matrix. That means most users have interacted with most items. However, in fact, most people only buy few items. That means, especially in tourism platform, because people rarely rebuy tours. So this results in you will have a extremely sparse matrix. Like in our experiments, the sparsity is 99.91%, which means this matrix is almost empty. So the cosine similarity is very hard to compute. So the question is, how do we cope with sparse data? So we use the model-based approach. The model-based approach is a machine learning method, and it's called the matrix vectorization. And your goal is to find, because you have a big sparse matrix, your goal is to find two smaller matrices, which are the latent features of items and users. So let's use this picture to describe this idea. So you have a sparse matrix on the left, and you want to vectorize it into two smaller matrices. And in the first, on the left side, it's an m by n matrix, and you vectorize them into an m by r and r by n matrix. And the multiplication of these two matrices will approximate the left matrix. So what you want to do is to estimate the values inside these two matrices. So the problem becomes, if you have a user vector called UI and an item vector called VJ, and you have the rating for this user on a specific item J, what you want is the UI.VJ will close to the real rating Rij. So your problem becomes you want to minimize the error between Rij and the UI.VJ. And there are many approaches to solve this kind of problem, like the singular value decomposition, or the ALS, alternative least square, or stochastic gradient descent. So I will not jump into the details here. If you are interested in this method, you can just Google it. So let's see some performance here. In this example, the user bought several tea bags and there's and some teas. So the system recommends him some tea bags also, like this. So the data is not with such a high sparsity, which is over 99%. You can see the matrix vectorization still have some good results here. Okay, so the matrix factorization, in fact, it can be thought as a linear neural network. So for those guys who are familiar with neural network, you are no stranger to this picture. You can see, if I have R neurons, which correspond to number of vectors, and the activation function of these neurons are linear, then given you and user I, you want to have an output, the rating of item j. So you have to estimate this parameter here and this parameter here. So you can see that the entire network is exactly a dot product, so which is the same as the matrix factorization. So if you have m users and n items and r latent vectors, the network will become like this. So this is very close to the current neural network model. So why we want to use neural network? Because of the flexibility. Recall that in matrix factorization, the number of vectors are fixed into R. So you have the same dimension for the user vector latent matrix and the item latent matrix. But in a neural network model, you can relieve the constraint. That means you can choose different dimension for the user vector and the item vector. And also you can combine other features, like some content-based features